Very good morning, students. Today we are going to continue with the topic BJT as an amplifier, whereas the problems based on that we are going to learn here. So there is a problem statement for a transistor circuit shown in the figure where uh, we have to find what is VCE when Vin is equal to 0 volt. B. What minimum value of IB is required to saturate this transistor if beta DC is 200, neglecting VCE SAT. C. Calculate the maximum values of RB when Vin is equal to 5 volt. So there is a transistor circuit given which is connected in common emitter mode. That is, the emitter terminal is grounded and input is given to the base of the transistor via the base resistor RB, and supply voltage of VCC 10 volt is applied to the collector of the terminal uh, via the collector resistance RC, whose value is given as 1 kilo ohms, and output is taken across the collector emitter terminal as Vout. So the first thing is we need to find what is VCE if the input is 0 volt. So when input Vin is equal to 0 volt, obviously the transistor will be in cutoff region, that is it acts as an open switch. So if it acts as an open switch, there will not be any current flow across the base current as well as the collector terminal. Hence the currents are 0 and the voltage VCC which is applied at the collector terminal will be dropped across the collector emitter of the transistor. So we can write VCE, that is the voltage drop across the collector emitter terminal, will be equal to VCC by neglecting the currents. So VCE will be equal to VCC, which is equal to the given 10 volt. And B part is the minimum value of IB we need to calculate. So in the last class we have derived the equation for IB minimum as IC SAT divided by beta DC. So in this, beta DC is given as 200, and whereas IC we need to calculate. IC is nothing but the voltage supply voltage VCC divided by the RC. So the supply voltage is given as 10 volt. 10 volt divided by the RC value 1 kilo ohms. I am getting IC as 10 milliamps. So this will substitute for IB minimum, and let us calculate what is IB minimum. So which is IC SAT divided by beta DC. So it is equal to 10 milliamps divided by 200. So you are getting 50 microamps. So this is the minimum value of base current needed to make the transistor to act in saturation region. So further increase of IB will ensure that the transistor remains in the saturation region. Thereby we have calculated the IB values. So next is C part is to calculate the minimum value of RB, where the Vin is equal to 5 volt. So when the transistor is when the input voltage of 5 volt is given, obviously the base emitter junction will be under forward bias. So if it is forward bias, we can say the base emitter junction will be equal to 0.7 volt, which is the cut-in voltage of the transistor. So the voltage across RB can be written as VRB is equal to the input voltage minus the voltage drop in the base emitter junction. So Vin is given as 5 volt minus the cut-in voltage 0.7 will be getting us 4.3 volt. So this will be the voltage across the which is applied across the base of the transistor. And they have asked to calculate the minimum value of RB. So what is the formula for calculating RB is, it is equal to the voltage VRB divided by the IB minimum, which is equal to 4.3 divided by 50 microamps. So if you divide, we will be getting the value of base resistance as 80 kilo ohms. This is how we will be able to calculate the base resistance RB. So the next application of the transistor is how we are going to make the transistor to act as a switch. So this is an important application of a transistor. So here the circuit diagram shown is a transistor when common emitter mode, which is used to turn on and off an LED. So we have a transistor connected in common emitter mode, and input is given to the base of the transistor via the base resistor RB, and the LED is connected at the collector of the transistor, and a supply voltage of plus VCC is given to the collector of the collector terminal of the transistor via the resistance RC. So now we are going to make the LED to glow, that is by giving an input square wave to the base of the transistor. So when a square wave is applied during the off position, that is when the input square wave is at 0 volt, we can say that the transistor is in off state, that is there is no input voltage applied to the base of the transistor. So thereby the transistor will be in off, so there will not be any base current as well as the collector current. Hence the LED which is connected across the collector of the transistor will not glow. So the transistor is in off position, that is in cutoff region, thereby the LED will be switched off. Now when the square wave goes to high level, that is when it is high, it is 1, this input square wave, it is enough to make the transistor to operate in on position, that is the base emitter junction, the base of the transistor will be enough to make the transistor to operate in the saturation region. Thereby we can see that the flow, there will be flow of base current across the base terminal. So this base current will be enough to make the transistor to work in saturation mode. So thereby we can see the flow of charge carriers across the collector current. So the collector current which is flowing across the collector terminal will make the LED to glow. So thereby during the square wave, when it is in high level, that is in 1, the LED will glow. When the square wave will be off, the LED will be in off position. So thereby we are making the transistor to act as a switch. That is when the input voltage is at 0 volt, it will be in off position. When it is at on position, that is when the square wave is high, you can see the glow of LED which is connected across the collector of the transistor. So this is the most important application of a transistor as a switch. Thank you.